Hey guys, welcome to this video. I will continue working through core concepts today, and as we go along I will explain some concepts and we will also look at some hands-on demo. Here's the rough plan for today's video. I will first start with discussing the general structure of Kubernetes object and the different approaches that we can take to create these objects. Then we will dive a bit deeper into understanding pods and its lifecycle phases. I'll speak briefly about the namespace creation as well, and after that I will give a rough overview of the Kubernetes architecture. So let's get started. General structure of Kubernetes object. Generally, all of the Kubernetes objects or resources like pods, deployments, services, jobs, cron jobs, they all have a very similar structure. So what you see here, API version, kind, metadata, spec, status, these are all the mandatory fields, and for almost all of the objects, this is the similar structure the definition file follows. So let's start with API version. It's similar to how you would version REST API if there are any breaking changes. So Kubernetes follows its own API versions, and generally you can get API version and all of this snippet basically for any object from the documentation. In terms of the kind, you can specify what kind of object you want, whether it's pod, deployment, quota, whatever it is. And then the metadata is for you as an application developer. So when you name your objects appropriately, when you provide them labels, it's easier in the future for you to find and target these pods. If you don't name them or you don't provide proper label, it will be difficult once your cluster grows and you have like a lot of pods or a lot of objects in your cluster. It will be difficult to select or query for those objects. Labels are also used as selectors by some of the Kubernetes objects like services or deployments, and we will be discussing about those in the future lectures. So labels are also pretty important. Then in the spec section, that is the specification for the object. You mention the desired state, what you are trying to achieve. So let's say if you're creating a pod, you probably have to mention the container and the image that you basically want to run. And then the status is not a mandatory field per se, it's just an empty object initially. And once you run the object, the status gets populated. On the right hand side, you can see the screenshot of the file that I've used for creating a pod. And if you see, there's a one-to-one mapping. So you mention API version, kind, in this case, I've mentioned pod. Metadata, you give some labels and the name of this particular object. And then in the spec section, you mention the containers. And if you notice, containers are basically an array. So you can have multiple containers in one pod. And there are some special scenarios where you do that, but we will come to that in the future lectures. For now, generally the rule is to have one container per pod. So you give the image and the name. This image can, when you just provide the name of the image like this, it looks for the image on Docker Hub, and if it is available, it pulls that image and creates the container. Now we will briefly take a look at all of the different approaches that you can use for creating these objects. There's imperative method, declarative, and hybrid. Imperative is the one that you use kubectl command, but all of the specification you want for that particular object you provide in the command itself. That's basically an imperative approach. In the declarative approach, you are using YAML files. So all of the specification, just like what we saw in the slide, this file is a definition file. So basically you just feed that file to the kubectl command and it will create the object from that file. The advantage of this is basically you can commit that file to some versioning system, and if your cluster goes down or restarts or whatever happens, you have a backup. You can again just create the object from that file. so you don't have to remember and keep typing those commands again and again. And then there is a hybrid approach. And I think for the exam, personally, this is the best approach. So using kubectl imperative command, you basically generate YAML files, and then you use that YAML file to create the objects. That way you have a record in your definition file, and in the future, if you need to edit or change any specification, you can do that in this definition file. Now in the command line, I will quickly show you how you can create a pod using an imperative, declarative, and a hybrid approach. Before I start showing you that, I want to say this one thing. This is very important. As soon as you enter the test environment and you enter the terminal, just type this command alias k equal to kubectl, and this will help you save few seconds here and there. So then you don't have to type the whole kubectl. You can just type k and rest of the command. So that is what I'm going to be using here. During the exam, you're also allowed to keep one tab open on the official documentation. So for the purposes of this demo, I will also be using the documentation, so you get familiar with how to navigate around and what to look for within the navigation, within the documentation. So to start with, I know for a fact, if I want to use imperative command to create a pod, the command starts with kubectl run, and I'm going to search in the documentation for this because I don't remember, let's say, rest of the command. So go to the search kubectl run, and here you'll see reference docs. On the left hand side, you will see all the different kubectl commands. What I'm looking for is run. And the first command that you see here, kubectl run name and image. All of the other parameters with the flags are optional. Whatever you see inside these brackets, they are basically optional. So you can choose to provide environment variables, port, and all of these other flags. But for this purpose, I'm just going to use kubectl run and this mandatory command here. If you remember from the definition file in the spec section, these were the two mandatory fields. So to specify the container, you had to provide the name of the container and the image. And this is what we are going to provide in our imperative command. And let me edit this. I'm going to name this as imperative, and the image that I'm going to use is Nginx. But right off the bat, let me tell you, if I press enter now, this will not create a pod. What this will create is a deployment. Let me show you, and after this, I will also show you the right way to just create a pod and not a deployment. So if you see on this line, deployment created. And don't worry about this deprecated message. We won't be using this command for creating deployments. It's only deprecated for deployments. And there's a newer version, and the command is slightly different for that. If you now inspect the pods, you'll see that indeed we do have a pod here, and it's in running status. But what is all of this ID that is attached here? So what ends up happening is, this command first created deployment with the name imperative. This deployment in turn spins up a replica set, and if you see the name of the deployment dash the ID of this replica set, then this replica set in turn creates a pod. So if you see it's considering the desired number of pod as 1, and then it spins up this pod, and the name of this pod is basically the name of deployment dash the ID of the replica set that created this, and then the ID of the pod. And the beautiful thing about this is basically if you try to delete this pod, you'll see that a new pod will be created. Let me show you. Just notice how long it takes for a pod to be killed. Later on I will show you a hack, and that will be very useful during the exam, so you don't have to wait for this long for the pod to be deleted. Okay, now if you inspect the pods, you'll see that a new one is running with a different ID. So what is happening here? Basically, the role of Kubernetes is to keep your app live 24/7, and it tries its best to do that. So as soon as it detects that one of the pod is killed, it will immediately spin up a new pod. And that is why you see, like, even if you try to kill a pod, it will keep coming up. So the only way to kill the whole thing is to delete the deployment itself. And now if you see, you don't have any pods in this namespace. So now you might be wondering, okay, we did create a deployment, but what if we just want to create a pod? So we'll be using the same command that we used, this, but we have to add an additional flag here. If you mention restart never, the Kubernetes engine will understand that you're not looking to create a deployment, you just want one-off pod, and it shouldn't care if the pod is deleted or whatever happens, it shouldn't attempt to restart. And now if you press enter, you'll see that the pod with the name imperative is created. If you inspect the elements, you have the pod with the exact name that we provided here. So that's basically the imperative command. And let me also quickly show you how to delete the pod without wasting any time in the exam. Let's first check if it is running. Yeah, it's running. Okay. Now CKAD delete pod, or you can also mention as PO. PO is the short name for pod. And you just add this flag grace period equal to 0 and this command force. And if you see, it gets quickly deleted. So what happens is when you're trying to delete the pod the normal way, Kubernetes allows it to gracefully die. But if you add these flags, then immediately it gets killed. It doesn't wait for it to gracefully end the processes and things like that. Okay, so that was imperative command. Let's move on to declarative one. Now for declarative approach, we have to create a pod definition file, and then we can create the pod using that pod definition file. So again, let me go back to documentation and let me search for it. Pod definition. And if you see create static pods, because these from the title itself, you can make out that this is going to be an explanation about the pod, but what you're looking for is the snippet to create the pod. You should just go to create static pods. And if you see here, this is the snippet for creating a pod. And I will just create .yaml, paste that snippet here, and then press Ctrl D. Now if I inspect the elements here, I can see this file. Just open this file if you need to edit anything in the file. And let's say I want to change the name of this pod. So I will change it to declarative. Labels I don't really want. Ports, I can choose to leave it there or I can delete it. It's optional. Let me just remove it. And the name I'll give Nginx. Save the file. And now if I type the command create -f, you have to give the flag -f when you're providing a file. And now if you see, the pod is created. If I inspect the pods, you have your pod running there. Next, let me show you the hybrid approach. So in the hybrid approach, basically you have a combination of the imperative command and the declarative way of doing things. Okay, what I mean by that is, so earlier we used this command, right? Let's use this again. I'll just change the name. And now instead of pressing enter and creating this object, what I will do is I will add this flag dry run. What it does is basically it will just uh, output the object, but it will not really create the object in the space. And if I say -o YAML, it will output the object in the form of YAML. So as you can see, this is the YAML that it would have generated. Now either I can copy and paste it in the file manually, or I can just add it like this, give it the file name. So what it will do is basically it will look for a file. If it doesn't find the file there, it will create the file with this name and then paste the whole snippet inside that. And now if I open that file, I'll see that it's there. Let's say I want to edit something here. Let's say instead of this, I want app front end. Save it, and now if I create, so you have both of your pods running. Hybrid approach is especially useful because let's say in the exam you have a certain task that is add a secret or anything like that. For that you cannot do it from the command line, so you first generate the snippet and then basically you go into that file and just add the sections that you want to add to it. So far we looked at all the different approaches and the ways that we can use to create Kubernetes objects. And now we will dive a bit deeper into the concept of pod. While I was learning about the concept of different objects in Kubernetes, I was able to relate to this one real world example for pods. Imagine this guy, he's an astronaut and he needs to go to the space. So for him to go to the space, you first wrap him inside this protective gear so that he can still function normally as a human being. And after you wrap him, you basically put him inside the spaceship, and then that spaceship deploys him into the outer space. In the similar fashion, imagine this is your app, your Node.js app, for example. Yeah, it can function on your computer, but to deploy it to a server with a different environment and the configuration, you first containerize it, right? You first wrap it inside a Docker container. You first wrap it inside a Docker container, which basically provides it the environment that is suitable for the app to function. And then that container, you deploy it inside the pod, which is then deployed in the Kubernetes cluster. So that's how you deploy your app. You cannot directly deploy it in the Kubernetes cluster. So in the Kubernetes world, pod is the smallest object, smallest unit, and it represents one instance of your app. So basically, when you want to scale your app, you are going to create more pods with those containers. And pod also provides the runtime for containers. So it can provide the Docker runtime for Docker containers, and it can be configured for to use different runtimes for different types of containers like Creo or RKT and other containers like that. And each pod basically has a unique IP address, and every container in this pod has the same IP address. They are in the same network namespace, and they can talk to each other using localhost. Also, when you have an astronaut on a spaceship or multiple astronauts on one spaceship, you also have the supplies that each one has to share. In a similar fashion, if you have multiple containers, they also share the resources inside the pod. So if you have some storage, persistent storage, each container can share the storage, and they can also transmit data to each other using this storage. Alright, so now let's move on and discuss the life cycle of the pod. And what you see here are the different phases that the pod goes through in a life cycle. It starts with the pending state, enters into a running state, and if everything goes well and the program is terminated without any errors, it goes into succeeded state. Otherwise, it goes into failed state, and if for some reason the status is unknown, it goes into unknown state. Let me elaborate more. So pending state is when your astronaut has got the approval to launch into the space, but it's waiting for the schedule or waiting for some last minute checks or something like that. So in Kubernetes scenario, your pod is accepted by the Kubernetes system, but now it is either waiting for the image to be pulled and container to be built, or it's waiting for it to be scheduled on the node. What about running state? Running state is when the pod is accepted into a node, it has been bound to a node, and at least one container inside this pod is running, and all the processes have started working. Succeeded is when your pod has terminated without any errors and it will not be restarted. Fail state is when the container has been terminated, but at least one container had some failure, like the exit code was non-zero status, and so in this case you will need to go in and debug and check what the issue is. And unknown state is that weird state where you don't know exactly what went wrong, and for some reason the state of the pod was not able to be obtained because there was some communication problem between the host and the pod. Host is generally a node in this case. And if all of this doesn't make sense right now, don't worry about it. Later on, when we are doing hands-on practice, I will show you all of these different states in the pod. Next, let's look at the concept of namespace. In Kubernetes, it's one big cluster, right? So you can basically divide this one physical cluster into smaller virtual clusters, and that is called namespace. So every resource in a single namespace has to have a unique name, but across the different namespaces, you don't need to maintain a unique name. Personally, I have found that namespaces are quite useful to avoid any kind of accidents. For example, in our company, we have different environments for production and staging. And if, let's say, you are playing with any of the resources, you're trying to edit something, in order for you not to accidentally change something on a live environment, it's better that these resources are divided into different namespaces. So if you actually type a command like kubectl edit pod and the pod name, but if you don't specify the namespace, it will actually go to a default namespace. So you have to be explicit. If you're trying to change something on a live environment, you have to be explicit and provide the flag namespace and mention the name of the namespace. We will look at all of this in the demo that is coming up next. Okay, so just like any resource in Kubernetes environment, namespace also is one of the resource. It's an object of Kubernetes. So like other objects, we can query namespace. And you see all of these namespaces that are out there. It's created by default by Kubernetes engine. And the shorthand for namespace is ns, so you can even do like ns, just like how you could do po for pod, ns is for namespace. Let us inspect all of the resources in this namespace or all of the pods. And currently you see we have two pods, declarative and hybrid. But we never actually mentioned what namespace we want to create these pods are. So what is the namespace of this? To check that, you can always do describe po. Let's say I want to check for hybrid, and I'll do grep namespace. And if you see here, we are in namespace default. When you don't explicitly provide which namespace you want to create the pod in, it usually goes to default. Now let's say I'm using an imperative command to create a pod, but I want it in a particular namespace called CKAD. So I'll first create this namespace. And you see there we have the namespace created. Now let us create a pod inside that namespace. So I will do hybrid to nginx restart equal to never. And I have to provide -n flag, which is for namespace CKAD. So as you see, hybrid, the pod with the name hybrid is created. But if you remember, you cannot create two resources with the same name in the same namespace. So that's why when you inspect the pods, you'll see that you only have one hybrid here. But to see the pod in another namespace, then you should add the flag, and then you'll see the hybrid one here. In the exam, you might be asked to first create a namespace, then create a pod inside that namespace, and then run certain operations on that pod. So what I suggest is, right off the bat, you set the default namespace to the one that you just created. And how you can do that is basically set context current namespace equal to CKAD. And now if you just inspect, you'll see hybrid over here. And when you delete the namespace, all of the resources inside that namespace gets deleted. So let me go back and set it to default first. So we are in default, and now I will try to delete it. If you see how long it is taking, the reason is because it's trying to first kill the pod and then it will delete the namespace. Now if you see, you don't have the namespace, and if you try to get that pod, it's not possible. You don't have it. Okay, so to summarize, in this video we looked at the general structure of the Kubernetes object and the different ways to create it. Then we looked at the pods and its lifecycle phases. We also looked at the demo of how to create objects using 3 different approaches. And towards the end, we just saw the namespace creation and briefly discussed the importance of namespace. At the beginning, I was also planning to include the Kubernetes architecture in this video, but I think the video is getting too long. So in the next video, I will start by covering the architecture, and then we will dive into the lab and we will practice some creation of pods, debugging the pods, and looking at different lifecycle phases in action. All right, thank you guys. Thank you for watching.